All right, so today we're going to talk about, for the water quality station, we're going to talk about first, what is a watershed? Well, a watershed is the entire area that flows or drains into a body of water. This river behind us, the Wabash River, all the area that drains to that is part of its watershed. It can extend hundreds, thousands of miles. It can go through state lines, countries. It doesn't matter. If it flows into it, it's part of the watershed. When we look at the water, we see it doesn't look all crystal clear. There's a lot of something in that, and that something is sediment. Now, sediment is Indiana's the #1 pollutant by volume is sediment. And sediment is anything that's got fine particles that's got washed up in there. And as we have here, we talked about it being the sand, the silt, the clay. All those finely spinning particles, that is the sediment that cloudies the water. Cloud makes the water cloudy, right? We can't see as well through that. Now, also things to think about. If we're not controlling erosion, it will pick up more sediment. And so we try to move buffer zones and things like that to stop the sediment from flowing into the water. Other things, you have a lot of sediment, it'll make it cloudy, it'll make it hard for aquatic things to breathe. They have to breathe in that water. They breathe something we call dissolved oxygen. Now note, when that sediment is darker, it's darker than the regular water. And so we're out here in the sun, we can really feel that warmth. I'm probably a little bit warmer than Claire because she's wearing a much lighter shirt than I am. And so that darker material is absorbing more of the energy of the sun, which gives us to something that could be a pollutant. Before we talk about pollutants, there's point source and non-point source pollutants. Point source is literally, you can point to and say, oh, I see that, that's pollutant, that's something flowing into it right there. Non-point source, like sediment, generally, we can't really point and say, oh yeah, it's for sure, it's this sediment here, it came from there. We can't do that. It's non-point source pollution. So let's see what our next slide is. Water temperature. Yes, if water flows over, like say, a hot parking lot and gets really warm, then flows into the water, you have warm water going in. That warm water is actually a pollutant at that point, and it can change that little ecosystem as part of it. And so we mentioned the darker absorbs more, and so it'll be warmer, and it supports or has less dissolved oxygen the warmer it is. And we know the fish will breathe that. Now, all these things are very important for us to think about, and we'll measure these.
So Stephen mentioned dissolved oxygen, and warmer water supports less dissolved oxygen. When we think about a water molecule, think about what a water molecule is. It's hydrogen and oxygen. It's actually 2 hydrogens and 1 oxygen. Now, is that 1 oxygen in a water molecule? Is that the dissolved oxygen? No, it's not. Dissolved oxygen is different. It's 2 oxygen atoms bonded together, and it shows up in between the water molecules within a body of water. And so that's something that we can take a measurement with a sensor. Dissolved oxygen it's again, how much dissolved oxygen is in the water. And not only do animals depend on that dissolved oxygen, they take in that dissolved oxygen, but also that's how they breathe, but also plants use that dissolved oxygen as well. The oxygen, in the dissolved oxygen in water is available to living aquatic organisms, and that can be both plants and animals. Higher levels of dissolved oxygen will support more forms of life. So the warmer the water is, the less dissolved oxygen that water is going to support. The cooler that water is, the more dissolved oxygen that water will support. Again, it's dissolved oxygen, just like the oxygen that you breathe in. If you take a deep breath, that same oxygen you're breathing in gets dissolved in between the water molecules, and that's what we can measure. If we change to our next slide, another measurement that we're going to take while you're out on the water is pH. So you encounter pH on a daily basis. If you think about some of the foods that you eat, so maybe you had orange juice for breakfast, or sometimes it's a nice treat to drink soda. Orange juice, soda, generally citrus foods, they have a lower pH. So the pH scale can range from 0 to 14, and any pH lower than 7 is considered acidic. A pH higher than 7 is considered basic. A lot of times bases taste bitter. And so if you think about something like soap, soap would be basic. And so it would be higher than a pH. And a pH value of 7, we talked about lower than 7 and higher than 7, but a pH of 7 is right at neutral. Another variable when we're thinking about water quality is nitrates. And nitrates are commonly found in decaying plants and animals. It's a natural byproduct of what happens when those aquatic life forms are decaying, and they're generally included in fertilizers. So you can imagine how if you fertilize a field, those fertilizers might eventually make their way into a body of water like a river. But the thing is, nitrates can also help plants grow. Sometimes we'll see that our body of water has a slight greenish tint to it, and that indicates maybe there's some algae growing in there. And so a lot of times the nitrates will feed those algae and other aquatic plants and help those kind of grow and flourish within a water body. When we're monitoring water quality, many times we'll use some sensors or probeware to take measurements of different things within the water. And two of those sensors that we're going to use today are the Vernier Go Direct dissolved oxygen sensor and pH sensor. So when you're first using these are Bluetooth devices, and so we will power those on. There's a soft green button, you power those on, and then we'll pair them with a device. The device might be a tablet, it might be a phone, it might be an iPad. Whatever you have, you're going to pair that on. It's important that when you're pairing it, that you look for your device that you're using. So on the back of the sensor, you'll see a barcode and a letter number combination, and you want to make sure that you're pairing the sensor on your device with the letter number combination on the back of the sensor. If we start with the pH probe, the pH sensor or pH probe is stored in a buffer solution. That buffer solution has a pH of 4. So that's a slightly acidic buffer solution. The water that you're testing, especially if it's a natural body of water, it's probably not going to have a pH of 4. So that's one thing to keep in mind. What you want to do is you're going to unscrew the cap, but you want to hold the sensor so that the cap is still on. We don't want to force the sensor down over, like down or across the pH sensor, because some pH sensors will have a glass bulb and the glass bulb can shatter. You also want to have a partner or a friend hold on to the pH bottle with the buffer solution so that it doesn't spill. We don't want water that we're testing to make its way into the buffer solution bottle, because that's what protects our sensor in between readings. So we're going to hold on to the cap with a couple of fingers, and then we're going to reach down and dip the sensor into the water. And I'm going to have Claire go ahead and demonstrate that. So Claire, you hold on to the cap, and then you'll kind of walk out and you'll just place the sensor into the water. And while one of your group members is actively taking the reading in the body of water, someone else is looking at the device. So again, the tablet, the phone, whatever your sensor is paired with, and you're going to be able to see that pH range changing as it's reading the water sample that you're taking. You want to wait for that water or for that pH reading to stabilize. It might take between 10 and 20 seconds for it to stabilize. If the last number is changing, that's okay. As long as most of the number is pretty consistent, then that's good. And when you have that pH reading, you can go ahead and make a note of that in the notes or the tablet that you're taking notes from. Okay, Claire, thank you. When we get the pH sensor back, we're going to carefully kind of shake it off, and then we'll carefully place it back into the collection bottle and then recap that bottle. The other sensor that we're going to use is the dissolved oxygen sensor. Now, unlike the pH sensor, the Vernier Go Direct dissolved oxygen sensor is a multi-sensor. That means that it measures a couple of different things all at the same time. So we're not only going to be measuring dissolved oxygen. Again, we'll uncap it, we'll hold on to that cap, and we'll keep this separate because we don't want our sample water getting into this. This is a storage bottle for it. But we want to make sure on the tablet or device that you're paired with that we have both the dissolved oxygen reading being taken. This will also measure water temperature. So there is a way that you can get on and make sure that both water temperature and dissolved oxygen readings are being taken at the same time. And again, we'll hold on to that cap and Claire will demonstrate placing that directly into our water. Claire is taking both the dissolved oxygen reading and a temperature reading. You should start seeing the numbers for those measurements as soon as the sensor is submerged in the water. It's important to not be sure that with both the pH reading and the dissolved oxygen / temperature reading, that the bottom of the probe, first of all, does not touch the bottom of the water bed. So we don't want to be hitting the bottom with that sensor, but we also don't want to be submerging the entire probe underwater. So we really just want the very bottom part of that sensor in the water.
All right. So for the sediment, I said we can actually see how clear the water is. We mentioned it is cloudy. It takes a couple people to do that. Now, we have shorter tubes, and then we have some longer tubes. We're going to practice, and we're going to, Sarah and Claire are going to take care of this with the longer tube this time, because that's what we have. When we do that, they'll come out here, and where I'm walking right now is all cloudy. So if we have a group, all of us are walking right here, it's cloudy, that's not a good measurement. And so they're going to step out just a little further, and they're going to fill this up by letting just the water flow in, the clear water flow in. All right, I'm going to let the two of you take this over. Now, they're going to fill this up with letting the water flow in, the clear water flow in. That's good. Right there. We're going to let the water flow into there, and we're going to fill that up. Yeah, squeeze. All right. The end piece, we want to make sure we clamp down so we keep the water in. Now, this takes two people. Now, what's going to happen, Claire's going to lower that, or Claire's going to like kneel down with that. Sarah's going to look in the top. With this tall one, she's going to have it down a lot lower, isn't she? Because she looks straight down the bottom. There's a black and white disc there. Sarah, make sure it's straight. It's not level. Can you see the black and white disc?
No.
All right. So Claire's going to let water out until Sarah can see the disc. As soon as Sarah can see the disc, she'll say, stop.
Okay, stop.
All right. Clamp that down, bring that up here. Now what we're going to do with our group is we're going to see how clear the water, when we look through it this way, it looks perfectly clear. But when we look down through it, we can barely see it. And so we're going to look, the highest level of where it is, and that's what we'll record. Now it's going to be different. It might be different based on where we are, what we're doing, but this lets us have an idea of how transparent the water is.